start with the map of Lebanon. Okay, in the middle of the country we have this line, which is the Yammouneh fault. So that's the plate boundary. And Nahna, we did excavation before in the area we called Yammouneh, and we started this in 2001. In fact, we did what we call trenches, excavations on the Yammouneh fault. And what we did this year is, in fact, we went to the area called Marjahine in the Hermel, Jrud al-Hermel, and we did excavation there, and we identified the fault. And that is something that has not been done before. And if you look at geological maps of the area, they don't put the fault there, which is...
So it wasn't known that the fault went all the way to this area in Hermel that you...
It wasn't known from geological maps. It wasn't known. The exact mapping of the fault in this area was not done. So they didn't expect the fault to happen in this basin. It does not show on the basin as if it did not exist. But now we've uncovered it. Now we know that we have a continuous fault from South Lebanon to North Lebanon and through Lebanon all the way up to Turkey, through Syria, of course. And mostly what we uncovered is that the main objective of this work is that we are able now to study all the old earthquakes that happened on the entire fault, entire Yammouneh fault, from South Lebanon up to the borders with the Syrian Republic in the north. So now we have excavations done along the entire fault. We can have a precise calendar of the earthquakes that happened in old times, and where did each of these earthquakes stop, where did others start, etc. Well, what we do in geology, and this field of geology is called paleoseismology, old earthquakes, study of old earthquakes. So what we do is that we identify, from looking at the landscape, we identify where could there be major faults. And in fact, big faults like the one we are dealing with is really one of the biggest on the surface of the planet. It is the boundary between two pieces of the Earth's surface. To the east, we have what we call the Arabian plate, or the Arabian piece. And to the west, we have what we call the African or Sinai plate. And that line that we uncovered, it's really a line that separates two pieces of the planet over 30 or 40 kilometers thick. So what lies on the east is moving independently from what lies on the west. See, so such features are as long as they are active, they are very obvious in the landscape. They modify the landscape. And in fact, the first thing that you can see when looking at the map of Lebanon is that line crossing the country. So that is the plate boundary. And in more details, we go over that line and we survey where could there be areas where the fault is crossing through recent deposits, recent sediments. If we can imagine this as if I'm comparing with new buildings and old buildings. If I want to, if let's say we have buildings 200 years old and buildings that have been built yesterday, and in between an earthquake happened. So the earthquake would destroy the previously existing buildings and not the young one. So that's why we look for such places like Marjahine, where we have deposits, recent deposits. So these recent sediments or deposits, they would have seen all the major earthquakes that happened until recently. So we're not interested in old sediments. And old sediments, they are old. They may have witnessed only old earthquakes, but we need to know where did the recent earthquakes happen. So we go over such areas like Marjahine or Jbab al-Himar, where we have an infill of sediments, continuous infill of sediments. And we know that the fault should go through these, they lie over that line. And we dig a trench. We dig a big hole that cuts astride the fault line. And we look at the sedimentary layers, and we see which ones are offset and which ones are not offset. So the ones that have not been offset or displaced means that since they were put in place, no earthquake happened yet. The old ones that have been offset means that they have witnessed at least one earthquake. So we look more carefully now in details which ones have been offset, small distances or large distances, and we take samples of these offset layers and date them. And that's how we can have an estimation of the ages of the different earthquakes that happened with time. And we know that in Lebanon, we are over a plate boundary that is active. So it means that it is still producing earthquakes. Although recently we didn't feel or witness a major earthquake, but we know from history that huge earthquakes happened. One of the deadliest earthquakes in human history happened in Lebanon along this same fault. It happened in 1202 AD. And it resulted in, according to the historians, more than 1 million people dead. 1 million dead people, 1 million people died between Lebanon and Syria and Palestine. So that's why such research is important, because we need to, the better we know about old earthquakes that happened in the area, the more we can anticipate for the future, or have a better understanding of the recurrence period of earthquakes and the strength of these earthquakes. And when we compare this fault, or when we compare the results along this fault with other faults we know of in the country, because this fault is the biggest, but it's not the only fault. We also have faults stretching along the anti-Lebanon range, mountain range, which is we call it the Sarghaya fault. And we have another big fault that crosses mostly in the offshore. We call the Mount Lebanon fault. So when we compare earthquakes happening on all these three faults, we can understand better how faults communicate with each other, because it's about forces that accumulate in the Earth's surface, in the rocks, and when these forces get to a certain limit, they break the rocks. So sometimes the forces are enough to break the fault to the east and not the fault to the west, etc. So one of them will trigger an earthquake and not the other. So they communicate together. So if we compare all these results between these three faults, we can understand how are these faults functioning.